AI video generation is getting just ridiculously good. We can now spin up these stunning photorealistic clips from literally a single image. But pretty much every model out there today shares one huge invisible weakness. They can show you what could happen, but they have no idea what should happen, based on, the actual laws of physics. And that invisible wall is what separates a pretty animation from a world you can actually believe in. Let's dig into why. All right, take a look at this. It's a beautiful, warm kitchen scene, right? Everything looks completely real. You got the cake, the steam coming off the pot, and that lump of fresh dough over on the right. Now, if this were real, what would happen if you reached out and poked that dough? You know intuitively that it would squish and give way. But how on earth do you teach that kind of intuition to an AI? And that right there is the million-dollar question. See, current AI models are phenomenal mimics. They've watched millions of videos of dough being squished, so sure, they can generate a video that looks plausible, but they don't understand the concepts behind it, things like force, mass, or elasticity. They're just expert pattern matchers, which means they're totally lost when you ask them to react to a new, specific action in a way that's physically accurate. This really gets us to the heart of the matter. AI video has a massive physics problem. There's this fundamental disconnect between how an AI sees the world and how the world actually, works. This slide just lays it out perfectly. On one hand, you have current AI, which mimics motion it's already seen, and it thinks in terms of a flat 2D grid of pixels. But on the other hand, you have the real world, which operates in 3D space. It's all about cause and effect, forces and torques. You can't just tell a normal AI, hey, apply 10 newtons of force right here, because it has absolutely no concept of what a here in 3D space is, or what a newton of force even means. So what's the fix? Well, the researchers behind this new project called RealWonder came up with a really brilliant idea. Instead of trying to cram the entire field of physics into an AI model, they decided to use a tool that already gets it, a physics simulator. They basically use it as a kind of bridge, or maybe a better word as a translator, between our world of physics and the AI's world of pixels. The whole process is this clever three-step translation. First, a person like you or me specifies a real physical action, like a push or a robot arm moving. Then, the physics simulator takes that action and crunches the numbers. It figures out all the consequences, but, and this is the key, it doesn't output complex equations. It just outputs simple visual information, like optical flow, which basically tells you how all the pixels are supposed to move. And finally, that motion guide gets handed off to the video model, which does what it's best at, painting a gorgeous, photorealistic video that follows those instructions perfectly. Okay, so let's look at how that big idea comes together in the full RealWonder system. It's this really elegant three-part pipeline that makes the whole thing happen in real time. So here's how the magic happens. It all starts with just one 2D picture. First, the system reconstructs a 3D version of that scene, and it even takes a guess at the material properties, like, is this thing squishy? Is it a liquid? Is it a hard solid? Then, the physics simulator kicks in, calculating how that 3D scene is going to change when you apply an action. Finally, a super efficient video model takes the original image and all that motion data from the simulator and generates the final high-resolution video. Each stage just builds perfectly on the last.
And the results? They're just incredible. Because the whole system is so efficient, it doesn't feel like you're waiting for a computer to render something. It feels like you're actually interacting with a digital reality in real time.
For instance, the system has no problem with deformable objects, stuff that squishes and bends when you apply a force. So right here, the user is telling a virtual robot arm to press down on this block of butter. And just like that, RealWonder simulates how the butter would realistically deform and squash under that pressure, generating this video totally on the fly. But it's not just for solids. The system's grasp of physics extends to the super complex world of fluids, too. In this one, the system is simulating what happens when you pour syrup over a cake. It actually predicts how the liquid would flow over that bumpy surface, drip down the sides, and pool at the bottom. And it's all based on the real principles of fluid dynamics. And to really show off its range, the system can even simulate invisible forces acting on gases. This is so cool. In this example, the user applies a sort of wind force field from off-screen. The system then simulates how that gust of wind would realistically mess with the rising steam, pushing it sideways in this turbulent, totally natural-looking way. And it pulls all of this off at over 13 frames per second. Now, that number is the real secret sauce here. It's fast enough to feel truly interactive, turning what could be a passive video generator into a dynamic tool that you can actually play with. This is so much more than just a cool tech demo. What we're looking at is a fundamental leap forward that could completely change how we and our AIs interact with the digital world. So why is this such a big deal? Well, for robotics, it means a robot can run millions of what-if scenarios before it ever moves a muscle in the real world. For AR and VR, it means creating virtual worlds that finally feel real and responsive. It could let AIs plan out complex tasks by actually predicting the physical results of their actions. And for artists and designers, it's like being handed a whole new set of creative tools where you can sculpt and manipulate digital materials as if they were real clay or water. The researchers really nailed it with this quote from their paper. RealWonder finally successfully bridges that huge gap between two different worlds, the mathematical world of physical understanding and the artistic world of making things look beautiful and real. And this just leaves us with a fascinating final thought. We're getting so close to creating digital worlds that don't just look real, but react like they're real. So when we can finally interact with digital matter just as if it were truly there, what incredible new things will we be inspired to create?